We are live. Hello, everyone. I can see the attendee count going up, and I saw a bunch of them already waiting to join. So let's just get started. Welcome to the first webinar of 2025 on Be Waste Wise. The topic for today's webinar is Understanding Critical Landfill Emissions Technology in North America. We have Jacob Wallace, who's an editor at Waste Diet, moderating this webinar. This is the first webinar that Jacob is moderating for us on Be Waste Wise. So thank you, Jacob, for your time. We've had others. We've had Megan and we've had Cole and Megan moderate in the past. So if you want to see the webinars that they've moderated, please go to the webinar section on our website. You should be able to find them there. Jacob has put together a panel of experts today. We have Dave Risk, who's a research chair in climate science and policy at St. Francis Xavier University. We have Jack Rowbottom, director of landfill gas collection sales at Loci Controls, and Catherine Blauvelt, Circular Economy Director at Industrious Labs. We've had significant interest for this panel. We've had a large number of registrations, and I see that the attendee count has already crossed 70. It's going to be a busy 1 hour. So over to you, Jacob. Just attendees, one last thing, please use the Q&A section. We're going to lose your questions in chat. So yeah, over to you, Jacob.
Awesome. Well, yeah, thank you much, Swetha, for organizing this for Be Waste Wise. Really appreciate you having me on. Always a pleasure for Waste Dive to be able to hop on and do a webinar here. So yeah, I'm excited to get going. And yeah, I want to start by speaking just plainly about the stakes and the opportunity we have here. We know last year is once again the warmest year on record, as has been the case for the past several years for the most part. We know that the greenhouse gases we're emitting today are warming our climate, and the waste industry has a role to play in addressing that. So the biggest source of emissions from the industry comes from landfills, which emit methane, which is a gas that's roughly 80 times more potent than carbon dioxide in the atmosphere over 20 years. So the models used by the U.S. Environmental Protection Agency and the waste industry here estimate that landfill emissions have dropped by a bit less than half since the 1990s, and that's thanks in large part to the growing adoption of gas capture systems in this country. But we know there's more we can do. As we'll discuss, the models we've used for decades now may not be adequately measuring all the methane that's released, due in part to undetected plumes that are escaping from our landfills. But using new technologies, we can identify those inefficiencies in gas capture systems more quickly than we have in the past and address them, which will allow the industry to do its part to address the climate crisis. It can also create new revenue opportunities for landfill owners through the production of electricity or renewable natural gas from that landfill gas, which has already led large landfill owners to become early adopters of some of the technologies that we'll discuss today. So, Catherine, I think it might be good to start with you. Industrious Labs has put out some reports that are questioning the reported emissions at some of the landfills that we have here across the U.S. Talk to me about why we're seeing a discrepancy between reported and actual emissions in some cases, and how should that color how we view the reported progress that we've made on landfill emissions so far?
Yeah, thank you. And excited to be part of this panel. So I'd say the bottom line is landfills leak methane. They're very dynamic bodies, right, of waste. They 365 days a year, 24/7 are being exposed to the elements. The waste is degrading. So you have a really complex system that it could be anything from a simple malfunction in the system to loss of cover integrity, right, due to rain. All that means landfills are going to emit methane, and methane is a carrier gas, which means that other pollutants are going to come along for the ride that can harm human health, right? So what we've been relying on for a long time is formulas to estimate, right, how much methane is coming out of the landfills. But those formulas can't, they're simplistic, right? They can't take into account or aren't taking into account even basic operational parameters like cover, which definitely impacts what's coming out of the landfill. So now we have technology, which I think we'll talk about a lot, which is sort of taking away the guesswork and showing direct measurements and direct observations of methane emissions. And that's leading to a number of scientific papers from NASA, from EPA and Carbon Mapper that have plainly shown emissions are 50%, sometimes even more, a greater factor greater than estimates, right? And again, it's validated by now we have satellites making the visible invisible, or sorry, switch that, making the invisible visible, right? So we're actually finding super emitter events at landfills across the country, at over half of the landfills that have been observed. So that really will colors just the fact that, okay, we have direct information. What are we going to do about it?
Yeah, absolutely. Thanks. Appreciate that. Yeah, and so we started to see some regulators take a closer look at this. In the US, the EPA has said that they're going to try and update the regulations for landfills at some point this year. And in Canada, we saw last year that Environment and Climate Change Canada, which is a regulator there, proposed new guidelines to update its own emissions regulations for landfills. So Dave, talk to us about those proposed changes and what gaps regulators there are trying to solve.
Sure. Well, Environment and Climate Change Canada is not actually a regulator right now, but they propose to be a regulator. So in Canada, the provinces have jurisdiction over these issues and waste management. And so we have an uneven patchwork across the country right now of requirements. And so those requirements are, I'd say, generally more stringent in British Columbia, Ontario, and Quebec. And so in those provinces, collection is required at landfills once they reach a certain size, and then surface monitoring is also required. So some obligation, to measure and monitor. In Alberta as well, there are collection-oriented rules, but in no other provinces are there any obligations for surface emission monitoring, and we don't have obligations for capture in all provinces. They're size related. Obviously, larger landfills are the more important ones to capture from. But anyways, that uneven patchwork of requirements is probably confusing for operators that operate across all provinces, and we have very similar scenario in oil and gas where we have these different requirements. But anyways, the federal government is wanting to step in here because we have national targets around methane, and waste sector is obviously important. And so Environment and Climate Change Canada does have the power to regulate transborder pollutants and that sort of thing. And methane rules have been proposed, and we're waiting for final draft language now. And what those rules would do is would set requirements in all provinces, all parts of the country, for collection and surface monitoring that are basically equivalent or maybe slightly more stringent than the provinces right now that have the most stringent requirements. So it's just bringing everybody up to the high bar that some provinces have already set.
Got it. Yeah. And Dave, maybe it'd also be good to hear a bit about the research that you're doing with Flux Lab, specifically regarding landfill emissions as well.
Yeah, sure. So we've done a number of big studies for like in the Canadian landfill space. So some of those studies have been similar to Carbon Mapper studies. We don't have them published yet, but we have some good estimates for landfill emissions across different provinces. And we also have done more in-depth studies at smaller numbers of landfills, where we've done what I call source apportionment. We're trying to figure out what proportion of emissions come from different features on the landfill surface. And our information in Canada strongly mirrors some of the recently published materials from the US and the EPA Carbon Mapper study, that the active working phase is very important, for example. And so we're also doing a huge study for EREF, and so we're into our I guess into our evaluating our second round of experiments. But we have a landfill at which we're working, and we're actually creating methane releases. It's a landfill that's closed and has a great collection system, doesn't really emit very much in the background. And so if we make emissions from the surface, we're pretty confident that those emissions come from our system. And so we're basically simulating landfill emissions and asking vendors to come and measure those. And so that EREF study, we first conducted in November 2023, and we did another round of experimentation with different vendors this past fall, and we have most of those evaluations complete, and we'll be able to present those in the coming months. But yeah, we certainly see that there are both good capabilities for measuring landfill methane emissions, and also that we need to work on some of the measurement methods as well. And it's exciting actually in those particular experiments to watch the technologies evolve. So we definitely see some differences in performance, augmented performance in vendors that are coming back to the site, and they're using their result basically to improve their technologies.
Awesome. Thanks, Dave. Yeah, so let's talk a bit more about some of those technologies. How quickly are we seeing landfill operators start to adopt things like satellite monitoring, drone monitoring, well monitoring, things like that? Like, do we feel like they're moving fast enough to start implementing those technologies? And Jack, maybe let's start with you. Talk to me about the technology that LOSI has and how you're seeing landfill operators, start to adopt it.
Yeah, thanks a lot, Jacob. So our technology provides real-time data collection within the well field. So we have a platform where you can view data across the entire well field. We have units that can go on landfill gas wells that collect CH4, CO2, oxygen, pressures, temperatures, all of that data, pretty similar to handheld units, how it's been done in the past. We also have Sentry data that monitor headers and regions of the landfill. And, we're seeing a lot of interest there, a lot of RNG and LFG to electric and flare projects are showing a lot of interest in that technology. As you can probably imagine, a lot of these projects are slow to develop, but as they roll out, we're able to talk with our clients and get these projects going. So I think there's a lot of room and opportunity to move faster, but it certainly is a challenge for these energy providers to build plants and expand. So that takes some time. Plus, new technology, you don't know what you don't know. So, but as we grow in the industry, the word of mouth spreads, and so we can see these RNG providers get a lot more interest and really want to see what our equipment can do. And so we provide, like I said, real-time data with the use of the equipment in the well field, but then we have a platform where you can view this data 24/7, 365, which really allows you to make informed decisions on data that's coming in, and you can really trend that data. Then we're able to automate the collection locations based upon thresholds and needs of the site. And so this technology can be really transformative. It can, it can help you in the moment identify, let's say, vacuums changing across the site and you're losing collection areas, which can impact emissions. But then also you can trend longer term and, make informed decisions on how you want to plan for the future. Do you need to drill wells in certain areas? In those sorts of things. So the technology can really help you in the moment, identify problems, because you can imagine the boots on the ground at these sites, if they have an issue with collection, quality or flow, any significant changes, they have to go run around in the well field and try to figure out where that's coming from. So that's a safety issue. But if they can use the equipment and the platform specifically, then that reduces a lot of time in the well field, and you take a more target approach to dealing with the problems, which has significant impact at a lot of our projects.
Awesome. Appreciate that, Jack. And yeah, I think at this point, questions for the panel. I'm curious, is there, just one technology that a landfill could add in order to capture its emissions, or how do we see these technologies start to kind of intersect, and where are there sort of synergies between different strategies to more adequately monitor and address these emissions?
Well, I'll jump in there from the measurement side. I'd say that there aren't any technologies that will be probably universally applicable, because we have different climates across the US and North America. We have requirements sometimes to do measurement in cold seasons, when some of the technologies we've been publishing a lot with lately, some of the imagers, for example, they don't work when there's snow on the ground. And so anyways, we need technologies that are appropriate for different climate types, and then also for different sizes of sites. So it's not just about measurement performance, but it's also about cost and deployability. And so what you might choose to implement at a large site might look different than a small site. I mean, I would add also that from the measurement standpoint, and trying to find leaks that pop up, and to try to get an idea of major sources on site, that some of the current regulatory requirements are effectively blocking a lot of the adoption of other technologies at the moment. So we have some limited requirements that in place across North America that mandate walking surveys, and really that's about it right now. And so those walking surveys, they don't cover all parts of the site, and they're pretty labor intensive, especially at the larger sites. And I think we can do better from the measurement standpoint, and it's important that that the regulators sort of open up pathways to measurement technologies that might be a better choice for managing emissions at their site, and not only maybe better for measurement, which means better for mitigation, but also lower cost. So that's a big driver behind the EREF testing program right now.
Yeah, I'll excuse me, piggyback on that. Absolutely agree. We're just in this game-changing moment, right? Because we have this tech really sitting on the shelf from a regulator perspective. They just haven't upgraded or updated regulations to really take advantage of for the complementary nature. Look, like today, a person walking across what could be many square miles of a landfill in all kinds of conditions 4 times a year, hoping to come across an invisible methane plume in a 100-foot grid panel, right? Like that's again, labor intensive, potentially dangerous, and as many studies and the EPA itself has noted, quite ineffective at finding land. So let's deploy drones. Let's utilize fixed sensors, right, in strategic places. There's just really great tech at a land that can be used at a landfill to just up our effectiveness. And that's where we really see states, and Colorado and California have already signaled in public forums that they're looking at this technology, right? Like, we've really got to take advantage of what's available. The one universal piece that I'd offer is detection from satellites and aircraft of these very large methane plumes. That's just very exciting. There's a study that was done in California that found out of all the methane found across the state, and it was hundreds and hundreds of sites surveyed, just a small amount of landfills were responsible for over 50% of the methane emissions found. But right now, it's just a needle in a haystack, right? We're hoping to come across, and again, be lucky to find those. That's the game-changing technology that satellites and Carbon Mapper and other eyes in the sky bring, is they can pinpoint a potential large event emission plume, and then the landfill operator can follow up and mitigate that, which would just be, again, extreme low-hanging fruit. Unfortunately, today, again, regulations just don't have that contemplated, right? So it's sort of guesswork, or we hope that mitigation happens, and that's just a clear piece that we can upgrade and make sure landfill operators are following up.
Got it. Yeah, I'm gonna pull in one question from the Q&A, and a reminder to the audience, you're welcome to throw them in how you want. I've got my questions too that I can ask, but if you have something more relevant to you, of course, I'd love to hear from you. So kind of going off of what you were saying, Catherine, talking about those satellites. So someone asked, landfill gas generation modeling uses mathematical equations to estimate generation rates. And how are satellites and drones estimating emissions using that technology? And are we just changing from one model method to another before trying to really understand, which model is best?
Yeah, I'll jump in just a note. And so we at Industrious Labs are really focusing on mitigation, right? Right now, if you think of firefighters, right? Methane's invisible. They're wandering around trying to find the fire that we can fight. If we can eliminate again that guesswork and get the firefighters pointed at the issue, that would be game changing for a super pollutant that's really heating up our atmosphere the fastest. So I just note that we have this technology that can spot and be that reconnaissance, right? To find methane, let's deploy that. Let's use those sensors and the low-side technology that's been discussed and I'll defer to Dave and others on. It's also important, of course, to upgrade our models on just how much methane's coming out of these landfills. That's sort of a separate but really important.
On the model side, we have been using measurements at some Canadian landfills to try to optimize the models. And certainly where we do have measurements that we have some confidence in, we can use those measurements to drive better parameterization of the model. So that's one thing that we can do. That's an area of intersection between models and measurement. They're not competing approaches. They should inform one another, really. And similarly, the models should inform what we expect to measure at sites when we arrive there. And we probably do need better models because the models right now, and they're geared for annual estimates, not sort of daily fluctuations in methane. And so that's one area of weakness. But in terms of the satellites and drones and how good they are, at our controlled release experiment, we have had satellite participation. The first round of experiments, our release rates weren't high enough. So it's important to understand that satellites are great at detecting point releases, and those are really focused areas of high rate release. They're less skilled at detecting releases that occur that might be the same magnitude, might be the same amount of gas moving, but where it occurs over a larger footprint. They're not quite as sensitive to those types of emissions. And really that's the type of emission that we're trying to simulate at our site, because the point source types of tests have been done largely for the satellites, and we have a really good understanding from oil and gas related studies how well they do for detecting point sources. So for these dispersed sources, I call them, we're still trying to understand how well they do. So the second time we did our experiment, we had the release rates high enough, but the weather wasn't very cooperative, and so unfortunately we didn't have a lot of success with the satellites. And what we really need to do, and what we're working on, is to do more routine and regular releases for satellites, and be prepared for when the skies are clear and they're flying over. And we're developing another adjunct site very close to the original site where we're on the gas grid, and at that site we'd be able to do releases for satellite more routinely. So I think that this is an area of probing. I think there's some good indications of success, but also we still have questions unanswered for sure. And I think the drones are coming along in terms of quantification. I think for small sites, and for if we're just looking at quantification, not just detection, but actually measuring how much, there are some good drone techs, but they work more work better at small landfill sites or small parts of the landfill. We call those sort of drone flux plane measurements. And it was not to get too technical in the weeds, but the other drone techs are the ones that compete with those are still coming along, and I think doing a nice job. So we'll see where they get to in the next year.
Yeah, definitely. Certainly a reminder that we're kind of on the bleeding edge of some of these new technologies. Although it's interesting to note, so the EPA has allowed landfills to use drones as part of their sort of monitoring compliance for, I guess, maybe a year now. And Canada, in its that proposed regulation as well, they have talked about potentially allowing similar use of drones. So we are starting to see that adoption for that technology, tick up where appropriate, obviously, like Dave was saying. But I'm curious in general, I think you mentioned this a bit earlier too, Dave, but like, where are we seeing regulations? Are they blocking, the adoption of these technologies? Are there places where regulators can move further to require some of these technologies if it seems like, they're ready for the mainstream? And that goes for everyone too.
So I think for measurement technologies, the approach that was taken in oil and gas regs is a little bit different than for landfills. They're, instead of defining a particular way of doing a measurement and monitoring, there's a framework that specifies the frequency of monitoring that would be needed for differently capable technology. So a measurement technology that's capable of detecting something very, very fine, very, very small emissions, because it'll detect numerous points across the landfill, will give a long list of repairs that are to be done to the operator. That list of repairs takes some time to work through, and those types of surveys would need to be done less frequently than if we're using, for example, an aerial technique that might offer lower sensitivity, but the idea is that it could still result in significant emission reductions if larger emissions were caught earlier. And so you do have to apply that type of tool more frequently. So anyways, I think that's an interesting framework that we can contemplate in the waste sector as well. It's not a perfect framework, but it's certainly interesting, and it would allow us, it's one pathway that would allow us to get away from sort of mandating a very specific type of measurement or needing to approve everything, including exactly how the measurements are done, because basically what's done on the oil and gas side is we just set the performance target, and the vendors themselves have to prove that they've gotten there by doing third-party testing. So I think that's one pathway where regulators in the waste space could adopt more alternative technologies.
Also, Jacob, I can chime in here. From our standpoint, we do see some dragging of feet, I think, because with our technology, we collect a ton of data. It's something that the industry really hasn't seen before or experienced. So I think a lot of operators out there, RNG providers, they're a little nervous at all that data, and how to handle it, how to manage it. And I think there's some question marks on the side of regulators of how they want to handle all of that data. So I think that has, especially over the last couple of years, limited the rollout of some of this technology, just because the industry wasn't quite ready for this and wasn't sure how to handle it. But definitely there was some, I guess, pioneers in the industry that put that aside and wanted to explore what we could do, and we've seen some fantastic results because of that. But and we're slowly starting to see those doors open. But I think definitely it questions around regulations probably limited growth and expansion of some of these technologies over the last couple of years for sure.
Can I ask, so when you talk about sort of that hesitancy, was it because they were like, well, we don't know what we would even do with the extra data, or we think this isn't something that regulators would allow, or where was that hesitancy coming from?
Probably a combination of a number of those things, but I think initially just how to manage it. Is this compliance data? Is it not compliance data? Is this, going to be required by regulators? These sorts of things. And so people weren't sure how to wrap their head around it. But I think as information has come out and data has come out on methane emissions at landfills, I think people are more open and want to get ahead of it. So I think we're starting to see that change in mentality, but it definitely was a struggle and a challenge in the last handful of years when people weren't sure how to handle all of that. So
yeah. And what do you tell people now when they have those concerns? What do you tell them about loci and is it compliance data, all that sort of stuff?
Yeah, I mean, up to this point, we've handled it by, you know, our data we consider operational data in the majority of our projects. But we absolutely have to stay compliant with, we can't be deploying this equipment and operating outside of, you know, the regulatory constraints. So our customers, so, you know, we're often in a situation where we have to work with the like RNG providers and then also a landfill. So we're sort of like a third party in between, and we have to meet the expectations of both. And that means staying compliant, but also increasing methane capture within the thresholds that's required by sites. And you know, in doing so, we've been able to bridge that gap oftentimes. But it is a bit tricky. Some people are a little more open to it, some aren't, and really they need to see the proof. And so, and that's what we try to provide them.
Got it. Yeah, and Catherine, any other thoughts on, what regulations could be requiring now that is, ready for prime time?
Yeah, I'd say, just reflecting on the fact that so many people live near landfills, and on the day to day are, exposed to, if the landfill obviously is managed in a way where pollution is escaping. There's health impacts. I'm thinking of the Chiquita Canyon landfill. It's currently on fire, but certainly well before that, residents were reporting really significant. We're talking about people waking up in the middle of the night and driving their family to go sleep in a parking lot because they just can't. They can't breathe well. So I'd say just taking a step back, there's an opportunity here where we can set communities up for success. That's the role of regulation, and set landfill operators up for success so that we have more confidence and more ability to reach better outcomes. And we've seen Colorado, there's lawsuits, there's a landfill that's this game of whack-a-mole, right? Where the worst outcomes happen. No one wants that, right? So that's really where upgrading regulation to bring in some of this new technology and frankly common sense practices that we've seen landfills take on, like let's manage the liquid levels in our pipes. That's really going to impact the efficiency of being able to collect gas successfully, right? Let's make sure the cover is of a quality that really helps keep the slow, rather the methane emission, right? So it's sort of a combo of upgrading both through sort of common sense operational practices and adopting and bringing in these new technologies. We could really see, just again, we're in this game-changing moment of delivering better outcomes for communities, and let's get out of the game of whack-a-mole, right? That's the opportunity. And I'll name, Washington, Oregon, Maryland have already upgraded their state regulations, are on schedule to look at them again, and we have Ohio, or rather Colorado and California up next. So it's a dynamic time.
Yeah. Yeah, these regulations are like actively changing, like as we have these conversations, definitely. I want to ask on the technology adoption side, what sort of investment will be required to scale these technologies? And are we seeing the necessary capital right now to do so?
I can jump in, Jacob. I think for RNG projects, it's pretty straightforward. You take a healthy project with a relatively healthy well field, not compromised by liquids, as Catherine mentioned. You see the investment in plants. These RNG plants are very, very expensive, but very little is done in the well field. And with our technology, you spend a fraction of that cost for visibility in the well field, and the return on investment, I mean, a few percent can cover that cost and improvement in collection, which is very easy to do in a healthy well field. sub 5% typically with the RNG price. And so there is capital out there to do that, because there's a very compelling ROI. But it's a little more difficult with the landfill gas to electric and smaller projects because the cost. But we are seeing we can leverage other avenues like the voluntary carbon market that can allow those projects to be viable. So we're seeing some of that. So we're starting to see the expansion there, and projects take advantage of the voluntary carbon market and carbon credits generation. But then absolutely with the RNG projects, with the return on investment, that can happen pretty quickly in the improvement in collection and emission reduction. So I think the money is there and for these projects to expand.
Yeah, I think it's a great example in terms of cost, just again, where we want to support regulations really not creating unintended consequences or sort of unnecessary roadblocks. And, again, fully appreciate every landfill is different. There's different types of landfills. But for those landfills that are just, acres and acres, following current regulatory requirements to do that required monitoring, that's a lot of time. That's a lot of human hours. And just being able to, again, take on, that reconnaissance that a drone or, other, laser, there's all different technologies that could really shave off a lot of those human hours and be that needed complement. That's sort of that sweet spot that we're really excited about and would hope to. I think we're there, right, in terms of where the tech is to see regulators include that in their framework.
So Jacob, you mentioned investment, and I think immediately of the dollar investment, and I think of business models, because I think that we've just been chatting a bit about energy opportunities, and I think that managing methane just for methane's sake is much harder than trying to tie it to a good business opportunity, whether it's carbon credits or energy. And I think that certainly energy is of interest and in the frame right now, and these landfills offer substantial low-hanging fruit when it comes to bioenergy. And I don't know what the situation is exactly in the US, but we definitely have well differentiated pricing for biogas and fossil gas in Canada, and I assume that's the case in the US as well. But I also think of interest in terms of investment in terms of interest as well. And so I think, like, on our side, and so we're a university-based research group, and we're asked for data a lot of the time. I think that although I suggest that regulators could do more to incorporate, for example, alternative measurement in their regulations, they're certainly interested in doing that, and they're certainly investing sort of time to engage, and we're talking a lot and trying to figure out how that could be done. And basically they need to be shown some of the data as well. And so at the transformational moment, when we need the information, we're collecting it at the same time. And so I think the regulators have shown a lot of interest in wanting to do things differently, but are needing to be able to back up their choices. I think that a lot of the vendors are, the tech vendors are working really hard right now. And again, there's, spending money, actual dollar investments, and obviously show a lot of interest in capturing some of that market. And then we also have the operators. So through EREF, we have a lot of funding going towards methane related programs right now. And definitely the operators are interested either in just reducing methane, or else maybe going farther and capturing every molecule, right, for really highly effective energy projects.
Got it. Yeah, I'm going to turn to another question from the Q&A here. So Thomas mentions EPA RINs and California LCFS. And for those who don't know what those are basically incentive programs for, in the case of the EPA, that's a US federal program that incentivizes alternative transportation fuels. So as opposed to something that's petroleum-based, it's based on a different resource, which for the waste industry means that natural gas fuel created by essentially upgrading landfill gas allows you to generate EPA RIN credits, which you can then generate revenue from. So that's become a driver of landfill operators, essentially, building these landfill gas to RNG projects so that they can take advantage of that, transportation fuel market, we call it here. So it's an economic incentive for these landfills to, capture as much gas as possible and find a source of revenue from it. And California's low carbon fuel standard program does basically the same thing, we'll say for the sake of time. So Thomas asks, EPA RINs and the California LCFS incentives encourage landfills to develop RNG projects instead of landfill gas to electricity projects. And Thomas says that, RNG projects make a trade-off. They collect less landfill gas to attain higher gas quality to facilitate RNG conversion from landfill gas. So how do you reconcile measurement of landfill gas emissions with these programs that encourage projects that collect landfill gas differently?
Yeah, I think that's a classic example of, if you will, like it's sort of, we're solving for two different problems or opportunities, if you will, right? So, when you collect that landfill gas, right, you got to do something with it. And it's absolutely possible to turn that and refine it, right, into that something to heat people's homes or electricity. And that is a energy solution, right? That's what you're doing with that gas. And as this person points out, it doesn't necessarily solve the uncontrolled fugitive methane emissions at a landfill, which, as we all know, right, are supercharging, heating up the atmosphere and contributing to very costly and harmful climate change, right? So we've got to reconcile, right, and really manage for proactively those trade-offs, right, and those unintended consequences. And that, in California's case, you've got to have the state regulator, ARB or CARB, right, on deck and the landfill operators should absolutely be part of that conversation, sharing data around, okay, like what does that look like at a landfill when you're again your main focus has shifted and into how do we collect high quality gas for RNG. Okay, let's figure out what are the mitigative and sort of operational and monitoring measures that need to be in place to make sure we don't have a really bad outcome in terms of methane emissions. So that's like, I think the California is like right there in the middle of needing to figure that out. And the positive is, again, like none of the solutions on the table are like splitting atom, really challenging. It's more a matter of actually taking the intention to figure it out.
Jacob, I'll jump in here as well. And piggyback off Catherine, with our technology, what we're seeing, of course, these RNG projects have much tighter gas specifications than, say, your LFG to electric or flare projects. And so it takes a higher level of visibility. So our data, the real-time data we collect, we're constantly looking for, you're monitoring your pressures and making sure you're not having positive pressures across the well field, which we know can lead to emissions. And it's a tighter threshold. So you take somebody who's walking around a landfill once a month and adjusting a valve. Well, that doesn't work in those situations when you have barometric pressure changes and all of these things, weather changes, temperature, which all can impact collection. So at one point you could have negative pressure and be compliant on a location, but then in 6 hours you may not be. That's where the real-time data collection and visibility comes into play. And that's also what I mentioned earlier, kind of bridging the gap between what the RNG provider needs and what the the landfill needs is this visibility, and then you can make informed decisions on, okay, are we having an issue in this area? Do we need to pull harder over here because this is where we tend to have odors, but maybe we don't have to pull so hard over here. And with that approach, you're able to kind of thread the needle between collection and making sure the site's compliant and you're not having emissions. And if there are problems with the real-time visibility and control across a well field, you can tailor automation and real-time alerting to make sure you're meeting all of those needs. And so I think in those situations, it's incredibly necessary to have that visibility and measurement, real-time measurement to manage those situations.
Got it. I like this question from the Q&A as well. I think it's Ati, sorry if I mispronounced that, but they asked, is there a way to effectively integrate remote sensing and ground-based sensors together for improved monitoring?
I think there are ways to do that. I think there are people thinking of how those link together. I mean, including even probably less direct vendor collaborations right now. And I think that there are a lot of pilot projects going on right now at landfills. Bigger operators are trialing different technologies together, different remote sensing and ground-based monitoring together, and they're trying to work it out, and they're undertaking reconciliation between those sort of examination, trying to figure out why the measurements from satellite might be different than the ground-based measurements, for example. And anyways, just trying to understand how those systems fit together. So I know of several large-scale trials that are underway, like pilots that are happening at different landfills that layer in different types of measurement technologies, and we've certainly been involved in evaluating some of those, and they're really interesting, and I think it's clear at some sites how they relate to one another, and less clear at other sites, and then anyways, as I said, there's no silver bullet on the ground either. So sometimes this satellite might be giving us clear indications, and the drones might not be working as well because it's a windy site or something like that, and then it might be a flip situation if we look at the next site. So I think that we're really trying to figure that out, and there are definitely some progressive operators out there that are working on it, and they know it's coming, and they want to work with these technologies. And I think that the outcomes of those pilot projects are going to be really interesting and shape what happens in the future.
Yeah. Oh, sorry. Go ahead, Catherine. Go ahead.
No, so yeah, would just piggyback on that in noting, look, we have Industrious Labs opportunity to work with local groups across the country, and really noticing just an uptick in, again, the visibility of the issue of emissions coming from landfills, right? And it's really creating a space for, we're seeing leading, I'm thinking of the Bowerman landfill in California, right? They're trialing and using drones and much more tech on their landfill, really wanting to be a good neighbor and reaching really effective capture of methane at Sampson County landfill, huge landfill in North Carolina, under a consent or settlement, I should say, with community groups that have held that or trying to hold that landfill accountable. They will be deploying drones, and so and that's just a few examples, right? So we are seeing absolutely landfills utilizing different tech, and really the common theme is the status quo isn't working, right? And no tech is going to be perfect, absolutely true, and we can do better, and that's why we're seeing just all this both voluntary adoption and frankly communities really holding landfills to a standard where they're more able to experience clean air and clean water. Over to you, Jeff.
Yeah, thanks, Catherine. I think there's huge potential, layering the technologies. You can imagine how powerful it'll be to be able to, use drone technology to see where your where some emissions are coming from, and then also tailor your automation and then real-time data to plan and remediate those issues. So I think layering in both of those is, as Dave mentioned, is kind of probably the future and where we're headed. And then you can have a really targeted and effective approach at dealing with that issue.
Yeah, and Catherine, it's funny you mentioned that Sampson County, North Carolina landfill, because in addition to the drones, they also recently installed an RNG system there. So, it's a classic example of a landfill where there's an identified issue with emissions there, and then the solution has become, let's use multiple technologies to try and figure out a way to address those emissions. And also for the landfill operator, they'll, generate some revenue as well from that RNG. So a good example of that. There are a couple of technical questions in the chat. I'm wondering if maybe we can just quickly knock out. One of them comes from Pedro. He says, what is the uncertainty level of these technologies to monitor methane using drones and satellites? Sometimes they can be expensive, and you get an uncertainty of 54%. So
yeah, so we're trying to confirm the uncertainties at the controlled release site, because when we apply the various technologies at an operational site, obviously we don't know the exact emission levels from each of the areas. So that's a difficult assessment. But yeah, the uncertainties can definitely be high. And in part they're high because we have different weather conditions every day that influence measurement. And anyways, there are a variety of factors, and I'd say that 54% is not that bad. In some cases, we'd like it to be better than that. That can still tell us if there's a big problem, though, and so it depends how we apply them. It's like finding the right fit for the technology. So if you do have a technology that's only good to 54%, well, then maybe it's not good for finding the smallest things or quantifying, but maybe it's really effective, or maybe it's really cheap. And so maybe you can use it all the time, and it can help screen for events that you weren't expecting. For example, maybe it's something that can be done passively, for example, like some type of continuous monitoring system. And all of a sudden one day you get an alert and it's beyond that 54% uncertainty. Maybe you have a very heavy emission that wasn't expected in some part of the site. So at any rate, I think it's trying to understand how we apply them correctly. So like we have to remember also that oil and gas has walked some of this terrain already. And we do have, for the time being anyways, still federal rules in the US for regulating methane in the oil and gas sector. And so the uncertainties, because oil and gas sites are smaller, obviously, and the emissions are smaller, there's actually higher uncertainty when we're measuring emissions at oil and gas sites than when we're doing it in landfills. This is actually what we find from our EREF studies. So we can sometimes have errors that are well over 50% in oil and gas, but they're still workable because they still allow us to triage, and we can identify something that's big from something that's medium from something that's small. And often for management, we don't actually need that much more. So if you're talking about creating inventories, then 54% might not be great, but for managing, 54% might be totally fine.
Yeah, appreciate that. And someone else asked if there are any technologies coming over from the oil and gas industry. The short answer is yes. Like you kind of alluded to, satellites is a good example of that. We've seen some of those satellite methane monitoring technologies originally used in oil and gas sites, and in some cases still are, used in to monitor methane releases from oil and gas sites. But we know that because they're capable of doing it there, in some cases, they're able to do it with waste sites as well. So landfills and also other facilities like wastewater treatment plants as well. So short answer is yes there. And then, another question. What is the minimum requirement for mass flow measurement coming from landfills? Does technology such as satellite mapping offer enough granularity and accuracy?
So I can jump in on Mike's question. So I don't think there is a minimum requirement right now. So there's no requirement anywhere in North America at the current time that I'm aware of for quantification. that is to measure how much. And so I don't think that there's a requirement for that, even at the very local level, or once emission leaks have been identified. I still don't think that there are any quantification requirements. So the required method right now is just for detection only, and that's through either walking or a drone equivalent technology, where we're dragging a tube behind a drone that emulates walking. And so yeah, right now there aren't any requirements like that, but it would be useful, I think, to move to more rate-based assessments where our measurement technologies, I think the industry is going to see this, pretty soon. And maybe we saw that a little bit in the first controlled release study, especially from LiDAR, and I think we'll see more from drones coming soon, is that we can not only detect, but we can quantify even to very low levels. And so we're going to be identifying emissions in some cases that are very small, like little leak sources, that don't require attention right away, and that we should focus on the top emitting locations first as we do repairs. And so yeah, anyways, all of that is all that should be, I hope, coming into play, where we're managing more on a rate-based and triage-based approach using measurement systems together. Allows us to prioritize better. We use those types of data for prioritization. So that would be great if we can move towards that.
Got it. Cool. I'm not sure, we might have time for one or two more questions, but I do want to get this one in as we sort of re-enter the real world from this panel. But will the new Trump administration help or hurt the landfill gas industry? Does drill baby drill reduce the value of methane, or maybe even that RNG fuel generated at landfills? And does the prospect of less EPA funding mean less progress on reducing landfill gas emissions? And I guess I should also note too, considering this is an international audience, I mean, we're talking about exiting Paris Climate Agreement as a possibility. Are we going to see progress slow because of some of this rhetoric that we've seen, or do we think that there is a path forward for these technologies and for progress to be made on this front?
Yeah, I'm so glad. I absolutely recognize the global reach of this audience, and I'm really excited about, the transferability of this technology across the globe. Folks know this, but last COP, the U.S. was one of many other countries that collectively are responsible for almost 50% of our global methane from organic waste, right? So those emissions, and a new declaration or a new commitment was made to for all those countries establish the specific reduction commitments, right? So that's happening, and of course every country will continue to have their own dynamics and their own course to chart, but that's really exciting, and so we're I'd say if anything, that really was a landmark focus on organic waste and the methane emissions that it's creating. And then frankly, technology is a driver, right? And it's making the invisible visible, and that public square of seeing where we're having really large point source emission events is, I'd say it will continue to shape the conversation and help policymakers focus. And regardless of who's in the White House, we've certainly seen clean air and clean water. There's a landfill in the US in every state. And we have to remember that human impact of people living by landfills and experiencing impacts. And we saw Republican Congressman Mike Garcia in California weigh in and support folks being impacted by the Chiquita Canyon landfill there. So I'm just really excited about that. No matter what, people are really looking to have good outcomes for communities, and that's a pretty durable goal.
I think, Jacob, you could have a whole webinar that you moderate on this topic potentially. And maybe we'll see where things go. I'd say I sit in Canada, obviously, and I think, you know, there are a lot of countries that are still going forward. And so it's like internationally, it's, you know, just would be disappointing to see some of the actions roll back. But on an international level, it's maybe a bit of an aberration. I think that a lot has changed since the first Trump presidency, and on the oil and gas side, actually, we don't expect you know, huge differences to the way that U.S. manages methane, because a lot of we have these international frameworks that we're developing right now for market standards, and market access will require a certain level of methane performance, and so it's not just up to one country anymore and what they want to do. If they want to export and sell and play internationally, they'll need to do that. And we see countries joining the global methane pledge that we wouldn't have expected, like Azerbaijan, Turkmenistan, and so they're doing something. And so we always blamed them in North America for perhaps not doing enough. And so anyways, I think it's interesting, and you know, I hope that we don't lose momentum. I think that the energy topic might play well, you know, from landfills and methane reduction, having the energy opportunities at the end. So at any rate, I think that that's an opportunity.
Awesome. I think we might be at time, Swetha.
We are at time.
Okay, cool.
Any last thoughts from anyone before we wrap up? Okay, all right, looks like no one has to add anything. This is just for the audience. We're gonna run, I mean, I know Catherine has dropped her email in chat, and all the others are available on LinkedIn if you want to connect further. And I see that you've all chatted with each other as well. So that's great. For the pending questions, we will try to, we'll share the questions with the panelists, and whatever responses come in will go on our website in a couple of weeks. It's wastewise.be. So if you haven't signed up to our newsletter, please sign up. You will get an alert once it's up on our website. We have another webinar happening next week, so please go to our website and sign up for that as well. Thanks a lot, Jacob. Thanks a lot, Catherine, Jack, and Dave. I mean, I think you managed to cover a lot of ground in the last 1 hour, so thanks a lot for your time. Have a good day. Bye-bye.
Thanks, everyone.
Thanks, everyone. Thanks.